Excuse me.
Yo, we'll put. Jameson, I have a better idea. Since we all like these penguins, why don't we put you in the Russian soup experiment?
Yes. Raise your hand if you like.
All right, time out. Time out. Homework.
Jameson, you just go to sleep.
Percents. All right, you're in a lot of chit chat. You're supposed to be getting your homework out. Lunch, not lunch. I'll put you down. All right, any questions on the homework before we grade it? I gave you two options yesterday of doing percents. You can pick whichever one you like, either the proportion method or turn it into a decimal, move the decimal place. Either one's fine. It's entirely up to you. Any questions? Yes. Number 27 says the following. It says,
You didn't have to do 27. Yeah, we did.
but to answer your question, and there was a reason why I didn't give you 27. Next year I'll give you 27, but not this year. It says 1 over 25. 1 over 200. Sorry.
That's why I was confused.
All right, everybody else hush. I will give you next year's lesson 1 year in advance. So it says 1 over 200%. Okay. The definition of a percent is what? Over here, dude. All right. Put her name on it. That whole class period. Be careful. Most people a long time do that. All right, back up here. The definition of percent is a number out of 100. All right, this is next year's class. I'm not giving you any fractions this year. You guys aren't paying attention to that. Okay. So if this is a number out of 100, I take the number. Why did I put a 1? And I put it over 100. Looks very weird. Okay. Put that one over 1. And this is a fraction over a fraction. A fraction bar means what mathematically? And when you divide fractions, you do a copy dot flip. So I take the top, copy. I flip the bottom. And then multiply straight across. That's next year, not this year.
So
Anyway, that's how it's done. Yeah, it's a very, very, very small number, isn't it? All right. All right, for the ones that I assign, which is 1 through 8 and 13 through 24, here are the answers. Number 1 is 3 over 4. Number 2 is 3 over 5. Number 3 is 9 over 20. Number 4 is 19 over 20. Number 5 is 3 over 25. Number 6 is 19 over 25. Number 7 is 1 and 1/4. 5 over 4 is fine. Yeah. And number 8 is 2 and 1/5 or 11 over 5. Okay. All right. Those were the easy ones. Just changing a percent to a fraction, put the number over 100. All right. More challenging ones are 13 through 24. 13 is 80%. 14 is 25%. 15 is 30%. 16 is 4%. Just 4%, not 44. 44%. 17 is 48%. 18 is 85%. 19 is 62%. 20 is 175%. 21 is 220%. Remember, they give you a mixed number, change it to an improper fraction first. 220. 22 is 344%. 23 is 102%. And 24, the last one, is 124%. 344%.
All you have to do is add a 1 and put it the number. It's number 24 times 24.
Yeah, that's a coincidence, isn't it? Yes.
What day is
Today's the 28th. All right, make sure your names are on that. Hey, some of you, and I making this recommendation yesterday, some of you probably weren't too impressed with yesterday's class. You're not going to be impressed with today's class. I mean, like the complexity of it, like challenging or easy math. It's easy math. I'm just going to say yesterday and today, you're not listening, you're talking. Yesterday and today become confusing today only because it's, can you stop? Yesterday and today become confusing only because we're still dealing with percents. I'm going to give you new rules for a new scenario. And for many of you, this is where it becomes, okay, this is all getting rattled around in my head. I knew what to do when we were in class, then I got home and I kind of forgot what to do. I highly encourage you right now to start your resource card for the test. Yesterday, we learned two things, changing a fraction to a percent and a percent to a fraction. We're going to get two more things today. They are ridiculously easy, each one. And every year I get these kids are like, no, I got everything. I understand it. It was really easy when we were doing it. It is. But all together, put, all the stuff that we do in this chapter becomes very confusing. Start a resource card already. So on your resource card, you should have fraction to percent, the rules, whatever notes you need for yourself, and percents to fraction. Today, we're going to do the truly easiest ones. They are so easy that kids screw them up. Literally, they are so easy that kids screw it up. How do they screw it up? Because the rule for both processes are exactly the same minus one word. And if you mess up that one word, you get absolutely the wrong answer. So how do you not screw it up? You have a resource card that tells you exactly what to do. You read it, you follow it, and obviously you do your homework so you get some practice on it. All right, without further ado, here we go. I'm on the right slide here. All right, your homework tonight shall be, calendar first. Nothing going on until Tuesday, quiz on Tuesday. All right, here's your homework, 1 through 24 all. This is literally, 10 minutes worth of homework, right? As long as you don't screw up the rule, you can do it very quickly. It's not that much homework. Like I said, you're not going to be that impressed with today's lesson. It's fairly simple, but boy, do kids screw it up. I won't repeat myself for a third time. Resource card. 1 through 24 all. All right, here we go. Oh, by the way, did I talk about the test yesterday? I don't remember. Most of you did fine. Some of you did horrendously bad. And it was very obvious the kids that were paying attention in the chapter, the kids that weren't. I had 3 perfect papers, I want to say. Yeah, 3 perfect papers. And then a whole bunch of people make one of the most common mistakes, even though I can't talk too much because she hasn't finished the test, is you forgot to put units on the word problems. You said x equals 2. That's not one of the answers, by the way. X equals 2, and you forgot to put x equals 2 centimeters.
Oopsies.
Hey, you want to talk to Dr. K about that? Then turn around. All right, percent and decimals, the easiest of the percent problems. Once again, I'm probably to blame for it as well too, since I say this is the easiest one, then a lot of kids don't pay enough attention to it. It is that easy, and it is just one word difference between one to the other, and boy, can you mess this up if you don't know which way to go. So think about this. From the last class, we learned that percent was a number compared to 100, or a number out of 100. Okay, this was the example I used yesterday. If you had a grade level that had 40 boys and 60 girls, and we compared the boys to the entire class, there's 100 people in the class. Therefore, there's 40 out of 100. 40 out of the 100 students are boys. That's literally the definition of percent. A number compared to 100. Therefore, we throw a percent symbol, we're done. So that's percent symbol. Last class, we also talked about how to change a fraction to a percent. To convert a fraction to a percent, we set up a proportion. This is method number 1. Method number 2 is we make it to a decimal. But method number 1, we make it into a proportion. We do cross multiplication. 1 times 100 is equal to 2 times n, and we solve that. We get to 50. And then the process said attach a percent symbol and you're done. So 1/2 is 50% using method number 1. 50%, the second thing we did was we changed a fraction, or sorry, a percent back into a fraction. The steps are you take the number, you put it over 100, and you reduce. So we get 50% is equal to 1/2. Today, we're going to be changing decimals to percents and percents to decimals. Okay, both of those. They are ridiculously easy to do. As you move up higher in math, this year is kind of like a transition year. Math teachers also transition from, I don't know, kindergarten all the way up to say 7th grade. Math teachers just say, I'm smart, you're not, listen to me, this is the rule, right? Have you ever questioned your math teacher? Why is that so?
Yes.
You should, right? I could be lying to you, right? All of the other classes, a lot of times you ask why. Why is that so? Why do we have this law? Why do we put periods at the end of sentences? You question teachers. No one ever questions a math teacher until you get to about 8th grade. In 8th grade and higher, that question of why does it work is what math teachers primarily focus on, right? Because it would be bad for them. And that's why I showed you that comic strip yesterday, because math is one of the few subjects where in order for me to teach you math, I gotta prove it to you. You just can't take my word for it. Yeah, this is the formula for area of a triangle. If I can't prove it to you, how do you even know it's true? So this is kind of a transition year. We do a little bit of it, but mostly we're still in the old mode of like, trust me, this is true. Start next year, that's not the case. I will prove everything. Actually, I'm not going to be a teacher next year, but your teacher will prove everything to you in 8th grade and 9th grade and 10th grade and 11th grade and 12th grade. If you go to take math in college, that's what they do. That's why math is true. That's why the only thing that's allowed in the math are true things. In science, right? We allow a lot of things in science that aren't even true. Or we find out later on they're not true because we think it's true until experimentation, investigation proves it otherwise. Math is the one subject where the only thing that's allowed into the door are true things, right? We don't allow things that might be true. They have to be proven to. All right, off my soapbox. Math rules. So this presents a problem, right? Since I can no longer lie to you and just say, trust me, I got to prove things to you. So a lot of times in math, there's like these 2 phases of instruction. There's a phase where I give you an explanation of where it comes from. Hey, this is why it is true. And that's all great and dandy. And then what happens is some smart kid, right, figures out, wait a minute, that's all great, but I found an easier way of doing it. And their easier way of doing it is the application of the explanation. I prove it to you, and then we find out there is an easier way of doing things. But the easier way of doing things is not the explanation of why it works. It's just they notice a pattern. Hey, it looks like all you're doing is changing that top number into the bottom number, right? That's an application of it. That's like I see a pattern going on. But the explanation of it is why it works. So I'm gonna show you. Here's your first, I don't know, dive into higher level math. Is I'm gonna first prove to you why it works, and then for the actual doing the homework, we're gonna say that's great. Now, what's the easy way to do it? Does everybody kind of understand what I'm saying? I'm gonna show why it works. And then we're going to notice a pattern. We'll say, oh, all I have to do is this. Now, some students are like, I don't care about this. Just show me the easy way to doing it, right? That's great. But that whole speech I gave you about, I can't just do things and say, trust me, it's true. I have to prove things to you. All right, so here we go. Percents to decimal. Here's why it is true. Hey, there's a percent, yes? Well, percents can be written as fractions, yes? I just did. I can reduce that to 1/2, right? And we already know that you can turn fractions to decimals. How do you turn a fraction to a decimal? Say again? How do we turn a fraction into a decimal? Ace?
You put a 0 point in front of it.
Absolutely not. How do we turn a fraction into a decimal?
You divide the top by the bottom.
Divide the top by the bottom, long division, top by the bottom, we get to 0.5. So before we talk about the application, the easier way of doing it, here's the proof of why it works. Why does it work? Because you can always change a percent to a fraction You can always change a fraction to a decimal. Is this what you will be doing tonight? Oh, heck no, because there's an easier way of doing it. But the easier way is just noticing a pattern. It's not the truth behind why it works. Here's another one. Can you write 20% as a fraction? What do you write?
20 over 100.
Okay, which reduces to,
1/50.
and you can turn 1/5 into a decimal by,
Divide the top by the bottom.
and I get 0.2. So I changed a percent into a decimal. One more time. Hold thought. One more time. Can I write that as a fraction?
Yes.
What is it?
0.5 over 100.
Which reduces to,
1/4.
which is what is a decimal?
0.25.
Okay. So now here comes the, wait, there's an easier way of doing it. I'm going to point out one last time. What we're noticing is a pattern. We're not noticing the truth. We're noticing the pattern. Okay. This is the math truth. But oh yeah, tonight for homework, here comes the easy part. This is the application. Josh, what do you notice between this number and yellow? What do you notice between this number and yellow? What do you notice between this number and yellow?
That they both
Say it one more time.
that, well, the first one, they both have 5 in
You
it.
both have a 5. What about the second one?
Both have a 2.
What about the third one?
They both have 2.
In other words, it looks like the pattern is they both have exactly the same numbers. In fact, it looks like all we're doing, Caden, is,
We just, if it has a 0 in it, we just remove the 0.
yeah, but these have decimals, these don't. What does it look like we're doing?
Math.
It looks like all we're doing is moving a decimal place. Do you see it?
Do we have to put
Where is the decimal place right now?
It's to the left.
Right.
To the right.
And it looks like the answer, all we have to do is,
Move it once to the left.
if we move it once to the left, that would be 5.0.
I'm so smart.
That's not what that says. Doesn't say 5.0.
Why is
It says 0.5. So it doesn't look like we're moving it once. It looks like we're moving it to which direction?
left?
That is the application.
Do we?
All right. This is the math that proves why it's true. But the application is what? What do you do to change a percent to a decimal?
You move the decimal place 2 times to the left.
That is why I started off this class by saying I'm going to show you a very easy rule, but boy, can you screw this up if you forget which direction to move it. Okay, so yes, we've now discovered the easy way of doing this. Write this down. All right, if I turn a 50% into a decimal, it looks like I'm moving it 2 places to the left. It looks like I'm moving it 2 places to the left. Yes, therefore, that is the rule that we were writing down in box number 1. In box number 1, write this down. To convert a percent to a decimal, I'm not talking really loud as I normally do. Ben, close the door. I just noticed it's open. The teacher's going to hate me. Well, I know, but at least with the door, there's a chance that it won't be as loud. Thank you, Ben. To convert a percent to a decimal, you move the decimal 2 places to the left. You're like, what? Is that it? There's no actual quote, quote, math? Well, you got to count 1, 2.
That's it? You like
There's no long division. There's no multiplication. There's no addition, subtraction. There's no squaring, square rooting. There's just, you move a decimal place to the left. Why do I say kids screw this up?
because they
might
just move
it
You just forget, or they only move it 1 time. Typically, the mistake is they move it in the wrong direction. This is why you put it on a resource card. You're like, well, I'll always remember moving left. No, you won't. You'll forget.
It was like you could have 5% and the kid me thing just move it once.
And just move it once. And that is a really common mistake.
That'll be 0.50 instead of just
Correct.
0.2.
Ace,
Can you also move it 3 times like for this one?
you only move it twice.
Okay.
You only move it twice. All right, so that's the whole rule. So, well, what's so hard? There's nothing hard about this. I said you got 10 minutes of homework tonight. You're going to move a decimal place to the left and you're done.
What?
Right? There's nothing hard here. Hey, the only issue here generally that students have a problem with is besides forgetting which direction is, where is the decimal to start with? Like, is there a decimal right now?
Yes.
Well, there is, but is there visibly a decimal right now? No, there isn't. So a lot of students are looking like, well, where's the decimal? Well, remember, if there is no decimal in any number, It's always to the right. Okay. All right. So that might be. So if you need steps, write this down. If you're like, wait, I don't need steps to move something 2 places to the left, then don't write it down. But for those that need steps, well, you remove the percent symbol. You add a decimal place if necessary, right? Sometimes your number will already have a decimal place, right? It might be like 1.2%. Well, there's already a decimal place. Guess what step number 3 is?
Move the decimal to the left 2 times.
Then you simply need to do it. I'm going to show you loops. I recommend touching with your pencil lead. So I recommend doing 1, 2 rather than putting in loops, although I will show you loops. The book shows you loops. Most math teachers show you loops. I've just over the years, I've changed my thought about putting loops. I just see too many kids do crummy loops and they mess it up. I've yet to see someone, if they touch, count incorrectly. Okay, who's got a question? Yes. All right, we'll get there when we get there. All right. By the way, you can drop any extra zeros, right? I don't need to put 0.50. I will always put a leading 0. That tells me it's a decimal number. You don't have to have a leading 0, but it is recommended that you put one. Yeah.
So can you divide percentages with decimals?
You certainly can. Right, but you have to convert them both to decimals first. Or you could change 1% to a percent. You can do that too. All right, so converting percent to decimal, we just move the decimal place 2 to the left, not to the right, 2 to the left. Step number 1, remove the percent symbol. Step number 2, if you need to put a decimal, we put a decimal. And we move it 2 to the left. 1, 2, put the new decimal place, and we're done. Notice I added a leading 0. Who's lost? Who's unimpressed? You should be. This is not much math going on here. All right. So box number 2, here we go. Beat me to it. It says 50.
We're only on box number 2?
Yeah.
Done.
59%. Step number 1, remove the decimal place. Step number 2, add a decimal if necessary. Step number 3, move it twice to the left. 1, 2, add your decimal,
0.59.
and you're done.
Do you have to add 0?
So the only reason we put this is if you don't put a leading 0, it's still right? Your calculator never puts a leading 0, right? But if you leave it off and your decimal is like really small, doesn't that look like a 59?
No, it looks like a 0.
I mean, if I put a 0, then you're like, oh, there must be a decimal place involved, right? If I just put 0.59 and my decimal is kind of weak or small, you might not even notice that's a decimal number.
If you put a 0 in front, I'm just gonna think that
You put a 0 in front of it, you know there's a decimal.
No,
involved.
you put a 0 in front of it. I think you made a typo and I didn't even notice.
Say again?
Will you mark off?
No, never. But I'm saying I do recommend putting a 0 in front of it. Yeah.
Around the typo on the back.
All right. Well, we point out when I get there.
Or a problem with the.
So I have some students, and then I know that you never paid attention in class, will look at this and guess what they will tell me?
What?
It's already a decimal. Because they see a decimal, like, well, it's already a decimal. I don't need to do anything. It's not. It's got a percent symbol. It's a percent. So the rule doesn't change even if there's visibly a decimal. You know, the previous ones, 59%, there was no decimal to start with. Now there is a decimal. That doesn't make it a decimal number. That makes it technically a decimal percent. Okay, but it's still a percent. The steps don't change. I get rid of the percent. Now this is box 3. Everybody got it done? Okay. We move it 2 places to the left. I don't need to add a decimal. 1, 2, add the decimal, and I'm done. So the answer is
0.135.
questions?
No.
Yes. Let's get through a little bit more of the lesson. All right. Box 4. Some kids, once again, they're used to dealing with percents between 0 and 100. As soon as we go over 100, they lose their brain. Like, wait, how's that even a percent? It can be a percent. It can have 26 numbers in percent symbol. To convert them to a decimal, we still do the same procedure. We get rid of the percent symbol. We add a decimal if necessary. I need to add one this time. We move it 2 places to the left. 1, 2, add a decimal place.
3.68.
So if you ever have a decimal number that is larger than 1, it's larger than 100%. This one was 368%. So as you look at the decimal number, if it's bigger than 1, it's over 100%. If you have a number that's between 0 and 1, like the previous 0.59, then that is between 0 and 100%. We got this?
No.
All right. So Malachi, do this one. This will be the maybe the third one that I'll see kids mess this up. Go ahead, talk me through it. That's the rule to change a percent to a decimal. We get rid of the decimal. Oh. What's step 1? No, that's not what it says. Get rid of the percent symbol. So we're not going to get rid of the zeros. We're going to get rid of the percent symbol. That's step 1. Now what? Did you write the rules down? I suggest you write the rules down, or the steps. Go ahead. Step number 2, after you remove the percent symbol, is to, what do you guys got written down? Everybody else?
You move the decimal 2 to the left.
2 to the left. You want to know why kids make a mistake on this?
Because there's nothing else to move.
There's nothing here. And for some reason, immediately they're like, well, that doesn't seem right. Therefore, I should move it to the right because that's where the quote, quote, numbers are that aren't 0. The rule doesn't change. It doesn't say move to the right. It says move to the left. So I need to move it how many places to the left?
2.
So that means I need to add some zeros in this case. Well, if we move it 2 places to the left, there's your first one, and I'm out of numbers, so I need to
Put a 0.
add a 0. I will have most people make this one. If there's one that's going to be wrong, it's this one right here. Every student will look at this and they'll say, there's no numbers there. I must have to move it to the right then. The rule doesn't change just because there's no numbers. By no numbers, I mean like there's physically not any numbers over there. You add zeros. Who's lost on this? That is a crazy small number. 0.00046. But that's the steps. That's the procedure. Malachi, you got them written down now? The steps? Never changes. We will get to test day, and unfortunately, I will have kids miss this. I don't know why. The rule never changes. Move it 2 places to the left every time. It should be like easy test. Oh, don't even need to give them a chapter 9 test because it's just percents. Yet I will still have students make a mistake on this. What's up?
For the percent part, imagine that you get a pizza and that's how big the slices are.
You're gonna be very hungry. All right.
Yes, you will be.
Imagine that's the size of the entire pizza.
All right. So here we go. Box 6. How many people got
None.
all 6 of them correct? You're 100% sure.
100.
All right, Malachi, if you do all of these right, you can go to the bathroom. Go.
Alright.
First one.
Get rid of the seconds.
Okay.
And then put decimal.
Okay. So 0.46. Very good. First one's good.
Alright. Get rid of the percent.
All right, it's gone.
You need to add a 0. And then put decimal.
So what's the answer?
0.7.
Say it again.
0.7.
You said move it 2 places. 1, 2. Does that say 0.7? If the decimal place is now here, does that now say 0.7? Read that exactly the way it appears right now. Oh, that's different than 0.7. So if you put a leading 0, 0.07. If you don't put a leading 0, 0.07. All right, next one. Everybody gets this one, right? Therefore, the answer is, how many places did you move it? 1, 2. Read it again. So I'm just going to say that if you physically do it, you'll get it right. Top one? So you get, now you're cooking.
What?
Okay, and we can leave off the zeros, right? So just 2. Last one.
You need to add a 0.
There you go.
So it's 0 or 0.00034.
Perfect, go to the bathroom. All right. I know that Malachi's got this. The question is, do you guys have this?
Yes.
All right, every year that I've taught this, that's the response I always get. Like, oh, heck yeah, I got this. Keegan's completely asleep right now. Keegan, do you have it?
He just
Yeah.
put it down.
All right. But the issue for this is that I will have kids say they got it, and we'll get testing, and they don't have it. What's up?
Okay, so,
What box are we talking about?
so when you convert a decimal to a percent, are you just doing the opposite then?
Well, let's finish this first, and we'll talk about that. All right. So I'll have every kid tell me they got this. We'll get to test day, and I'll have mistakes. You tell me why there's mistakes.
Because they didn't listen in class.
Because they didn't listen to me telling them that you will forget this. You didn't listen to me when I said that if you don't have this written on a resource card, you will forget this. You didn't listen to me when I said the most common one missed is this one. Because they look at this and like, oh, I don't want to move it to the left. The numbers are to the right. I want to move it to the right. Occasionally I'll get kids miss this because they'll say, well, it's already a decimal. This is now the one that's commonly missed. They'll move it 1 because there's no extra numbers over there, and they'll say it's 0.7.
I did
You got to
that.
move it 2 places. Those are the common. Most of the other ones kids do fine on. Please don't be that kid that gives away easy points when all we're doing is moving a decimal place 2 places to the left. Okay? All right. Can I say today was easy or hard?
Easy.
Have I been truthful now?
No,
Yes.
they're really hard.
All right. So this is what we just did. We converted percents to decimals. We converted percents to decimals. We converted percents to decimals. Noah, guess what we're going to do now?
Decimals to percent.
You're not Noah.
I am.
All right, Noah,
No in the art. What you said.
what did he say?
Decimals.
All right, so Noah, you got a good brain on you. How do you convert decimals to percents? Tell me the steps.
Move the decimal back twice again. Right.
To which direction?
Right.
All right. Yeah, it's literally that simple. Now, can you see why kids screwed up?
No.
It's 1 word difference. What's the word?
Left and right.
Left and right. So I will have kids, I don't need to memorize that. It's just moving the decimal place left or right. And then we get to test day, and literally, I'm not lying, they get everyone wrong because they moved it to the wrong direction. Please have this written on a resource card come test day, even if you think you have it memorized. All right, write this down, box 7. Yes, that is the rule. To convert a decimal to a percent, you're going to move it 2 decimal places, not to the left, to the right.
To the forward. To the north pole.
Ace,
Yes.
stop.
Okay.
To convert a decimal to a percent, you move it 2 decimal places to the right. So if that's my decimal,
50.
I move it 2 places to the right. 1, I need to add a 0. Last step would be to rewrite it
Percentage.
and tack on a percentage. So the other one had 3 steps. This one has 3 steps. If you need to write down the steps, write down the steps. Most students are okay with just moving it 2 places to the right. But here are steps for those that don't comprehend what it means to move it 2 places to the right.
Mr. Chartier, it's like brain math. Like you don't even need.
Okay, so you're gonna throw down the gauntlets and say, I'm not gonna be the kid that makes the silly mistake on the test?
Oh, I ain't saying that.
Okay,
I'm saying I'm gonna be the one who failed the entire test because they're too cocky at it.
yeah,
Yeah.
and that's generally what I see. Now, if the chapter ended right here, I think we would be okay. The problem with the chapter is there's 4 or 5 more sections to do, and there's different formulas that we get. I mean, this one has not a huge number of formulas, but there's more formulas to learn. And so this kind of gets lost And we get to test day, they're like, I don't need to worry about that. I need to worry about the one that I struggled on, right? This one, no one struggles on the day of, but we get to test day and people forget it. All right, so to convert a decimal to a percent, step number one is you move it 2 decimal places to the right. Hey, there's the decimal. So we move it 2 decimal places to the right. 1, 2.
Done.
We rewrite it
Slap on a percent.
and we slap on a percentage, and we're done. That's it. Nothing complicated.
Next.
This one I will also have students miss. Why? You gotta add a 0, and they're like reticent to add a 0. They're simply just, oh, there's no numbers over there, so maybe I only move it one place. No, it doesn't say move it once. It says move it twice. So I gotta move it twice, therefore I need to add a 0.
Fold it and then you remove.
If that helps, certainly.
Remove decimal,
I'm just saying.
slap on percentage. You have 80%.
Questions on what I just did? This was box number 9. I'm not doing a good job of saying do this. Yes.
Isn't there like, can't there be a decimal, be a percentage?
And we're going to do one here in a second. Okay, not this one. So when we convert this to a percent, we move it 2 decimals, box 10. We move it 2 places to the right. 1, 2. We add our decimal place. We slap on a percent symbol. Caden's question was this: what happens if I have a number? I don't know. Maybe it's 1.234, and we convert that to a percent. Okay, Caden, what do we do?
You move it to the right,
So if we move it 2 places to the right once, twice, what do we wind up with?
123.4. Okay.
So you can absolutely get a decimal percent.
Wow.
I should have just shown you this one. This is example number 11. Jasmine, walk me through it.
And similar to 16 on the
All right, move it 2 places to the right. 1, 2. Now what? Okay, how do I'm going to rewrite this one? You move it 2 places to the right. What's the number now? I can't hear you talking really softly. Where's the decimal place? So how do you say that number then? So 4.7, do you need to have the zeros in front of it? You don't, right? Okay, now what? And so the final answer is? And you're done. Okay, questions? Why do kids screw this up?
They're dumb.
It's usually that word right there. And it's not because they're dumb, right? It's because it's so easy. You blow off the fact that you got to have it either memorized or on a resource card. And you're, I'll remember which way to write. No, you won't. You'll screw it up.
I've already finished.
Make sure it's on a resource card. I said there was only 10 minutes worth of homework. Ace,
Yeah. Are you gonna make us do the next box by ourselves?
is it green?
I don't know.
Is it green? So yes, do the next one all by yourself.
Oh,
I don't know.
also, yeah. So the decimals that they're using are the answers from the last one, but they messed up the points.
Well, I wanted to make sure I had all the bases covered, so it's not an exact copy, but it's close.
I thought
And
it was trying.
I'm just being efficient. Nick, you already got all these done?
Yeah.
Efficient.
All of them, even homework.
Even homework, look at you.
No way.
Wow.
Yeah.
Even the test.
Yeah.
When?
Even life.
Today.
Jameson, you already got done?
Yes.
I already got it done.
This was
No.
2
This is
standard
math
college
for
test.
This is not math for kindergartners. Kindergartners would have no idea what this even means.
Yes, they
They
would.
know how to count.
Do you want to know something?
They don't know what this means.
Do you want to know something?
They don't know what a decimal number is in kindergarten.
Do you want to know something? I have a friend, she's in like
I'm gonna go
3rd grade. She's smarter for math than me. It's like ridiculous.
All right. Stay focused. Let's finish strong here.
It broke, Jameson. That's what happened.
All right, Riley, first one, upper left, what do you got?
I got, is it, 46.
That's what I got as well too. Lily, next one down.
I got 7.
7 with a percent symbol, yes? Because the rule says we move it 1 decimal place to the right, correct? She's furiously writing down something now.
Okay. 70%.
All right, I did not pay Lily to make that mistake, but I'm just going to tell you, that's a common mistake. Hopefully, Lily remembers this come test day, but this is a really common mistake that I don't know why I just see it all the year. Like they see that like, well, there's no numbers there, so I move it 1 decimal place. We go from a rule that everyone claims that's easy to remember to making a mistake. You can equally make that mistake as well too. All right, Kira, bottom left. Say it one more time. I think you left off a number there. Did I leave off a number?
No,
Okay.
wait, 16.9%.
Kira? I've never seen a kid make that mistake before, but obviously, if you're working fast, right, you can make that silly mistake. Kira, do the top right. No, it's not. I'm sure you got this one right. That's right. That's why I know you did it right. This is just a silly mistake down here. You just wrote too quick and you left off the 1. All right, Jameson, what do you got? No, you can do this one. 200%. Very good. All right. Jasmine, you got the last one. So do it. But you got to talk louder so we can all hear. Do it. On your paper or on the board, your head, I don't care, either one. So what's the answer? I think, I couldn't hear her. What did she say?
She said 0.034.
She said the right number. Very good. My goal is to get Jasmine to scream at least one time between now and the end of the year.
She's loud. She's just quiet in your class.
All right.
She's only quiet in your class.
Jasmine, is that true?
Yeah.
Yes.
All right. All right. So we did something seemingly impossible, yet it turns out to be very, very easy.
It's so impossible.
Your mistakes will be you forget to move in the right direction. You forget if there's a decimal involved. You forget what Lily did, right? If there's only 1 number there, those are the common mistakes. Please don't be that kid that makes common mistakes. As we move forward in the chapter, once again, we're going to move to much more challenging stuff than today. This can be easily forgotten very quickly. All right. For the 26th time today, I highly recommend, and maybe I'll make a requirement this time, you got to have it on a resource card. Please don't give away easy points on a test. I finished easily with 7 minutes to go. Now, some people have already finished their homework. Others of you haven't started. So for those that haven't started, get started on your homework.
Listen, if you get started on it right
Keegan,
now,
maybe
you'll
you
be
can
done.
get this one done.
Listen,
Right.
I'll sit here. I'll be a mental coach.
No. For those of you that have finished, I need you guys to be quiet and do something studious on another subject matter. Do you guys got any tests today?
No.
All right, study your Latin then.
We don't have. I don't have my life.
Study something else. All right,
I have a question. Can I study the road?
no. All right, make sure you stay in your seats for the 7 minutes. All right, Josh, you already did your homework?
No.
Get your homework done. No, we're not going to go to our lockers. You told me you already did your homework. You can ask if you can borrow Pierce's.
Can I see my test?
No, I'm not handing out any tests until she takes her test.
Can I see like what I got?
I can show you that. All right, e-learners, no one's live, but if there are any questions, send me a chat or an email. Hey, I just said, no one get out of your seat, and everyone is getting out of their seat. Noah, is that your homework from last night? Bring it up here. Bring me that basket too, please.